So how do we use complex conjugates? We use them when we have division questions. So just like the rule that you can't have a radical in a denominator, you also cannot have an imaginary number in a denominator. So our question is 10 over 2 minus I. And we want to simplify this to be in the form of a plus bi, so in the form of a complex number. So we're going to multiply the numerator and the denominator by the complex conjugate. Because we just determined that if we multiply by the complex conjugate, it will give us a real number. So I'm going to multiply the top and the bottom by the complex conjugate. And because I'm doing it to the top and the bottom, I'm not actually changing the question at all because anything over itself is 1. I'm just modifying it in order to simplify that denominator. In the numerator, we distribute, so we get 20 plus 2i. And in the denominator, let's look back at our rule. When we multiply something by its complex conjugate, those middle two terms, the o and the I, always cancel. Just finding the sum of perfect squares, where we take a squared plus b squared. So in this case, our a would equal 2, and our b would equal -1. So our final answer in the bottom of a squared plus b squared would be 4 plus 1. Then we can simplify this, 20 over 5 plus 2i over 5. And the reason that we do that is so we can simplify that 20 over 5. So 4 plus 2i over 5. We have our real part and we have our imaginary part. 4b. So to simplify this, we have to make sure that there's no I in the denominator. So we're going to multiply the numerator and the denominator by the complex conjugate. So the complex conjugate means that the real term stays the same and the imaginary term has the opposite sign. And the key is we're multiplying the top and the bottom by the complex conjugate. So when we multiply the numerator, we get 4 times -1. The outer is -8i, 4 times -2i. The inner is positive 3i. And the last is -3i times -2i, which is positive 6i squared. In the denominator, we're going to do a squared plus b squared, where a is -1 and b is -2. So we get -1 squared plus -2 squared. So we get 1 plus 4, which is 5. With your a squared plus b squared, obviously it doesn't matter if you use b as -2 or +2 because you're squaring it and it will equal 4. Then I'm going to go and simplify my numerator. So I'm going to collect like terms. And I'm also going to sub in I squared is equal to -1. So I get -4 minus 5i plus 6 times -1 all over 5. I will take -4. I got to collect that with -6 minus 5i. So -10 minus 5i all over 5, which is the same as -10 over 5 minus 5i over 5, which simplifies to be -2 minus I. And that's our final answer.